I would like to introduce Alfred Spector. Alfred, his bio was included in the booklet that you received, but he's a VP of Research and Special Initiatives. He's based in the New York office. One other neat fact about Alfred is that he played the piano this morning, and he likes to run. And I'm going to let him talk. Thank you.
Thanks very much. Yes, I guess that's a slightly unique fact. I was trying to think of what I could say that's more unique. The really bad thing is my toothbrush fell in the toilet this morning, if you really want to know the most unique fact. But you know, I'm a distributed systems person by training. So I carry a backup toothbrush. Lest you wondered what I did, because you know there was suspense. What do you do with it? So anyway, it no longer exists. It's been obliterated. Any case, I would like to first thank you all for coming. We hopefully will have a lot of fun together and learn from each other, which is the goal. So thanks for coming, and we'll have a good day and a half. I also want to thank Hannah and Hal for the work they've done in putting this together, with some people from our university relations team, like Jeff Walsh, for example, that have just done a tremendous job in organizing this. So thank you, Hal. Thank you, Hannah, for doing that. So without further ado, let me try to introduce a few topics that I think will be relevant for you. A couple things about this event. Google's a big company now. We could probably afford to stage a 500-person faculty summit and make it really big. But it's our view that if we did that, we'd lose the intimacy which allows for a lot of communication. So we really want this to be a small event. We thought about this actually just when I joined Google a few years back. We wanted to keep it small, but we wanted to make sure we kept seeing new people. So we sort of solved those simultaneous equations, and we realized we can't invite the same people over and over again. So typically, many of you were not here last year. In fact, I would guess almost none of you were here last year to a faculty summit. And we're going to keep rotating this over time. And that way, we'll keep this small, but we'll try to see a large number of faculty throughout the field. Our objectives are to explain some of the things we're doing. We obviously don't have time to explain everything in plenary sessions, but there are lots of Googlers around. So interact with them. Many of them were your students. Many of them are your friends and colleagues. Talk to them, and we can cover as many topics as we can. It's actually a lot easier to talk about things in informal situations. As you'll see, we have these roundtables in the afternoon when we have groups of, I don't know, 5 or 10 or 12 people or something like that that get together, and it's a much easier way to talk about a diverse set of subjects. Hope you learned something. Have fun. It's a fun campus. We try to make the environment fun. It's one of our approaches to try to stay vibrant and be innovative despite being growing, and hopefully you'll see that. So there are 3 themes in this. So to try to keep things somewhat focused, we've decided to focus on cloud computing, and in particular, some of the key aspects of it, like storage. So we won't discuss everything in cloud computing. It's now too big for if we did only that for a day and a half. But we'll pick and choose some topics that you'll find interesting, particularly things relating to scale, as you would guess, because that's something that we major in. Security and privacy, that's been an increasingly focused upon subject for all sorts of reasons in the commercial and even in diplomatic spaces. I was reading The Economist this morning, and it was a couple weeks ago, but there was a 4 or 5 page article on security, this in the domain of relationships between countries. But it was all about computer security and the issues. So we think this is a very important topic, and we'll touch, as we do this, on privacy as well, which is clearly also important, particularly given, for example, the growth of the social web. And what we want to talk about in the social web is some of the science and all the opportunities for advanced work in the social web. We're not doing product stuff around it. We're talking about science and technology in that domain. So the agenda looks roughly like this. You may have seen this. There's some major sort of presentations in this room that are in the mornings, and in the afternoon, later in the afternoon today, we have roundtable discussions we'll break up into. There'll be a nice cocktail reception and dinner. That's an important part of the event because it's a chance for us all to talk informally. All right, so a little bit more specifics here. I'm not going to read all of this now. You'll see this as it unfolds, but you'll see some various parts of this, and we'll present this as we go along. You see the research roundtables going on from 4 to 5:30 this afternoon, and tomorrow again we'll show you this again, but this is what we're doing in the morning tomorrow. Vince Cerf is here and will provide some closing remarks before we adjourn. And we'll see who else drops by during the course of the event. All right, so that's part one. Are there any questions on the conference, logistics, anything like that? Feel free to ask me, or if you don't have any broad questions, I'll keep going. All right. So two things I want to talk about that are the backdrop for what we do. So first is our mission. You've probably seen this. This is a mission statement that works. It does, to a very large degree, focus our company on very large amounts of what we do relate to this mission statement. It's worth stating because, frankly, it's why a lot of people come to Google to work. It's why a lot of people trust us, because the mission seems to be unarguably good. Organizing the world's information and making it useful seems like just a fundamentally good thing. And we are really focused on it. It's also great from the perspective that it is a great umbrella for a vast number of the grand challenge problems in computer science. So that's something that's great for the computer scientists amongst us. Now, the other side of Google, and one that we're very proud of, and by no means is it anything but a really exciting part of the business, is Google and its focus on commerce and what we can do to enable markets worldwide and, in fact, make money. So the Google commercial side is very large. I mean, we're talking about, a million advertisers worldwide that use the AdWords features that exist in Google search. And I could go on and read you the rest of these statistics. You can sort of scan them as I'm talking and see this. But this is billions of dollars or tens of billions of dollars in economic activity that one can count that we facilitate. And I think we break down barriers and make the world more efficient by what we do, create markets where they could not previously exist, for example. It's a worldwide phenomenon. And a reason to mention it here is not just for completeness, along with the primary mission, but also so much of the research focus, not only at Google, but in universities today, relate to auctions and algorithms and issues of that form. So there's an enormous amount of research that this kind of electronic marketplace stuff really engenders. So that could be the topic of a focus in some future faculty summit. It would be a perfectly valid thing to do, and you'll see that a lot of our research grants are, in fact, related to that. A lot of breadth. Won't go through this, but when you think about what's implied by our mission, almost every subject in computer science is something that's quite relevant to what we do. Now, given all that, we have to be innovative. We're, roughly speaking, 20-something thousand people at Google, roughly half in the engineering domain. We have to work at it to not get stodgy and to stay on the edge. So we think a lot about that. How do we do it? What's our focus on it? The first is that I think from Eric Schmidt, of course, a PhD in the field, our founders who are at Stanford, et cetera, the senior vice presidents who are typically PhDs in computer science, all the way through, this business is led by people that are committed to advancing technology. You might think the research VP has a hard sell on advanced things to the founders, et cetera, but it's not true. It's the other way around. I tend to be the pragmatic one, and they're always pushing for more. So it's an interesting dynamic in that regard. And we have to continue, we have this commitment, which I think enables us to try to keep doing new things in pretty much every domain. Second is, as I said already, the domain is really rich because of the mission statement as well as our focus on commerce, which both lead to really interesting problem areas. I think many of them are grand challenge problems. I'll try to portray a few of them later. Another aspect of Google, though, that has been important, and this is one that I think is a bit confounding to universities and to university graduate students that come work here, is that we have an internal consensus that the production issues of productizing a service and operating the service at scale are often every bit as challenging and fun as the pure invention of the concept to begin with. So what that argues to us is that we ultimately blur the boundaries between research and development and operation. And the roughly 1/3 PhDs, 1/3 masters, and 1/3 bachelors that we have at Google in the engineering groups are split among many different kinds of activities. We don't say the PhDs are, the pure thinkers and everybody else implements. It's a mixture, because the problems of doing things at the scale and with the quality that we aspire to are so great that it requires great minds and great innovation across the board. So we have tended to blur the boundaries of R&D at Google. The last part about why I think we have a good shot at remaining very innovative is what I call technical leverage. So 3 decisions were made pretty early on at Google that I think are very important. I'm going to do these in a slightly different order than listed here. The first is this focus on services. So lots of people had been talking about utility computing and service-oriented architectures and things, even as Google was being founded. But Google took it very seriously and really understood that providing services across a network, while in principle it's very similar to providing a packaged software offering, there really were very big differences in terms of the amount of time and cost it took to do a product release, the ability to gain huge economies of scale, and the like. And many more. I could spend 15 minutes as to how all that really played out. But it really was a game changer. It wasn't just some isomorphism between the product being local and remote, and then it was the same, and you could just, with location transparency, move something. It was very different to be able to run things in a central way for a broad audience. So that's number one. We have built the company around that thought, and we gain huge leverage from being able to rapidly release services. We built a common distributed infrastructure to make that feasible. So as you know, you've seen MapReduce things written about, and our GFS and other technologies that we've written about in the systems domain. Those systems that we built, a so-called common distributed system, give us a lot of leverage to releasing services rapidly. So if we want to go release a service that can be used by 100 million people, essentially overnight scaled to that, we have the technology to do that. Of course, we have to have the idea of something that people want, but in terms of the infrastructure, we have that available. So that's been a really big technical lever, which means very small numbers of people can do very large things fairly rapidly. And they're very interesting examples of it. We have a YouTube effort, I'll just mention, an Android product called Google Listen. And you put in search strings, and it compiles a sequence of podcasts that you may want to listen to on a drive to work. And we support huge numbers of people that do it. It's a very popular Android application. It was done with a couple people that built it, despite the fact it's a full-fledged Android product, and just you can do an enormous amount with leverage. The third thing I think that is fairly unique still for us is I have never seen a business that is more empirical in its focus. So that leads to a holistic approach to design. It means, what is it that we would measure? Does the design meet that measurement goal? And the measurement goal may be the number of clicks or the number of users, or whether something generates more revenue for our advertisers. Who knows what it is? There are many different things. But because we have this sort of central facility, we're in a very good position to measure. And those measurements impact everything we do. The measurements may be at a coarse grain, in which case we can decide, should we release a new interface or not? And we could do that at a coarse grain. They could be at a finer grain. It's a small change to an interface. A small percentage of the public is given that. If the public likes that more than what we had before, we use it. Otherwise, we don't. We throw it away and start over again. Or it could be at a very fine grain level, and then it's machine learning. And we're getting to the point with speech recognition where on a very fine grain, we can take reinforcement from correct recognitions of Google searches and feed that into our language models and do a better and better job with search, and do that not on the scale of a month or 2 or 3, but maybe on the scale of a week or a day at some time in the future. So that ability to do very fine-grained learning is an empirical kind of thing as well. Overall, those of us that have been in this field a long time have seen the field shift from being primarily analytical in nature, a mathematical discipline, to one which much more closely resembles the physical sciences as well because of this empirical notion. So computer science has been making this shift. It's by no means not an analytical science as well, but there's been this great addition of empiricism. The other part of, I think, innovation is culture. So we do focus on talent. We thank you. Bill Korn said this last night to those of you who were at the reception. We thank you for allowing your students to come to Google. We need them. They are Google. The talent of these students is remarkable, and we are indebted to the academic sphere for educating so many smart people. I already mentioned that we believe we have to distribute the talent throughout our organization because we think to impact the world at the scale we want to do it, it's production and research both. And that leads to this sort of second bullet on research here. And we do research in our engineering teams, and we do engineering in our research teams, and we try to blend it as much as we possibly can. So it's not an issue. If a few engineers want to go work on a research thing, it can happen if it's a longer term effort. If a few folks in research want to go and devote their time to a product launch, we wouldn't have any problem with that. We like it. We like that fluidity back and forth. So it means that our research careers are, in some sense, less pure than in traditional research labs and industry, but we think it's better. There is one other additional thing that makes this work well, and that is that our comparative advantage in research is data. So it makes a lot of sense for our researchers to be very close to in vivo systems so that they can operate on production systems. That's an advantage that we have big production systems with lots of users. That's an aspect of this that I think really helps us. I want to turn now to just a few themes and that I see going on that you should think about as we delve deeply into security and cloud computing and social networking topics. One of them is prodigiousness. So who thinks this is actually an English word, prodigiousness? I looked it up. I think it's a word. So I hope so, because I was a liberal arts major to a large degree, so I hope it's a word. But I wanted to use a word that didn't just say scale or some other word that you tune out on. I wanted a word that you'd think about a little bit. So we should be, all of us, I am, we should be astounded at the scale of the systems that we either build or are contemplating building over the next few years. Because it is, to a very large degree, what's driving everything that we talk about. So, if you don't have zettabyte on the tip of your tongue, you should. There are things we will now begin to measure in zettabytes. So that's exabyte we're used to probably for the most part, but zettabyte we have to think about. So just a couple of things. We publicized that we have a big table of 70 petabytes with 10 million operations per second hitting it. That's a big number. I remember, I was a student of Jim Gray in transaction processing. I remember a presentation at the High Performance Transaction Processing Systems Workshop in Asilomar a decade ago, maybe 15 years ago, I can't remember exactly, and we were wringing our hands over what were we going to do with more than 10,000 transactions per second or more than 20,000 transactions per second. The argument went that, no matter how big the airline, you just couldn't book enough reservations per day to warrant the scale of systems that we'd be capable of doing. And I remember this discussion, and we were all wondering if, we had worked ourselves out of a job. We didn't really think we did, but we were thinking about this. Doesn't seem to happen. And by the way, unlike, an airline reservation, which used to be, I can't remember the numbers, but 20 disk IOs. We tried to get it down to 20 disk IOs so that you could actually do it efficiently enough. These operations that we do for our users are not simple. A search is computationally intensive with enormous amounts of lookups going on in this, as an example. So we're doing very complicated operations, and with the desire to do semantic search and such things, it's even going to get more. So the world has gotten very big. We've talked about warehouse computers. So think of the warehouse effectively as the unit of computation. You know, you can, I'm not a hardware architect at this point. I don't really know the layouts of numbers of cores per chip, or number of chips per board, or number of boards per rack, and how many racks in a row by a column. But those numbers for the things that I just mentioned are not in any way outside of the realm of sensibility. Right, 100 cores per chip seems like a certainly valid thing to be happening. There's certainly experimental things where that's happened and more. So you look at that, that means you're going to end up with 16 million processing nodes in a building. A big building, but it's not impossible. In fact, it's likely in the future. So that's the kind of thing. So I did distributed systems when I was much younger. When I was a faculty member, we thought about 100 servers. This is a very big difference. 100 servers you can kind of manually configure. This is a fascinating problem in automatic management that requires to make something of this prodigiousness work. So storage today, you know, an exabyte is a kind of a number that you'd see in things. I can see a factor of 2 or 3, 2 orders of magnitude, 3 orders of magnitude happening. Users were at 10 to the 9th today, you know, roughly speaking, of these internet systems. One could get another factor of 10, everyone on the planet. We don't want a digital divide. I don't know what the number of devices are today. I don't know if anyone knows. I couldn't figure that out when I was writing this down. But, you know, you could see, you know, 100 devices per person, something like that. That certainly seems feasible. The network is getting towards, over the next few years, apparently 10 to the 21st bytes per year of transmission. So that's the first time I can use zettabyte in my career. A zettabyte of transmission per year over the internet. So that's, you know, if there were a billion users, that's 32 kilobytes per second continuously for every man, woman, and child in that billion people. And then the number of apps. So this is an amazing thing. Actually, that should be, that's 10 to the 5th is wrong. That's a mistake. That should be 10 to the 6th, getting to 10 to the 7th. The iPhone store is already 100,000-ish kinds of, I guess that's 10 to the 5th. I guess that is right after all. So anyway, 10 to the 5th apps, we're going to get to a much larger number. And in fact, if Hal Abelson and others that have been pushing, you know, end user programming are right, the numbers are going to be hundreds of millions of apps. And we'll talk a little bit about something we're doing in that. So it's just a huge, this is going to drive, I think, vast amounts of our focus in our careers in the field. All these things. The comment was made, you know, I'm selling my 95 car soon. I guess I'm trading in 1 ECU for 50 or something like that in the new car. I mean, it's an amazing change in cars over the 15 years since I've had it. So that's one thing. Second is distributed computing, perhaps leveraging this. Not surprisingly, we now have the distributed computing problem of all these clouds or big server complexes, whatever you want to call them, and vast numbers of endpoints or devices. How do we do that in an ideal way with all the load balancing and self-management and security monitoring, et cetera, that is needed for something of this superhuman scale complexity? So I think that's another theme that's behind this, certainly why we're talking about cloud computing today. One of the things I think Google is responsible to do for the academic community is try to tee up for the academic community the problems that we feel are relevant and we need help on and that the world should work on. By the way, people that are taking pictures, we'll post these if you want. So you're welcome to take pictures of them, but you will be happy to post them. Might save you some energy. I'll mail them to you, whatever you want. So one is, we've talked about this and we've funded, how do we deal with energy efficiency? So it's not a huge issue today in the general scheme of things, but it will become one. So we should be getting ahead of this issue. And there are lots of things to do. We've been discussing these kinds of topics for years, but I think it's relevant today, and the scale is now large enough. What's the server operating system design for these servers that are, or these individual processors or chips or racks that are running in these warehouses. We have a good abstraction for MapReduce, for batch. We have a good abstraction, we feel, for when there's embarrassing intertransaction parallelism, the multi-threading, the while true, do receive request, process, send response, do all those things in parallel. That's a pretty good model. We don't have other good unifying abstractions for parallelism. And people are worried about that, not just in the cloud, but on these multi-hundred, core chips that'll be running on our desktops. So that's a big topic. We are always interested in latency reduction. You heard I play the piano. I'm hoping that we'll reduce internet latency enough so that I'll still be able to accompany my children when they're in college remotely. But I think we have to get latencies of video conferencing down to 30, 40, 50 milliseconds for that to work. Otherwise, we'll be starting at the wrong time with respect to each other and getting very frustrated. But I think it may be feasible. We don't have good models of replication. It's not as if we don't have thousands of models of replication or tens of thousands of research papers in the subject, but we don't have good models of what to do when and how to sort of reduce this to good engineering. We're very interested in how to apply machine learning, not just to, say, all the crowdsourced information, but to big systems. So machine learning in systems. How do we do dynamic worldwide placement of data? So with all of these systems and interconnected warehouses, how do we do all that? And in fact, how do we do that keeping track of government regulation? I saw an article in the newspaper, there's discussion today about whether the EU will harmonize regulations on data, where data resides in the EU, or whether it's going to be on a country-by-country basis. A very interesting discussion topic. Obviously, whatever the rules are, we have to abide by those rules. That adds further complexity to data placement. Many security topics, but access control play an important role. How do you manage them and use them, given how many there are? Are there better privacy models, or is this sort of inevitably a complicated, multifaceted space? What's the user interface to all of this, given that we're not using a single computer, we're using any number of devices, and we want to seamlessly use those devices either in parallel or sequentially as you see fit against the cloud, which is hopefully always there. So a lot of challenges, I think, in this ideal distributed computing place. Another theme I wanted to mention that I've been beating the drum on is what I call totally transparent processing. So in our mission of organizing the world's information, but really many missions, we desire to provide communication and access to information regardless of device, so in a device transparent way. That's an old theme that's been going on for decades. A grand challenge problem has been to do it independent of human language with computer-based translation. We'd like to do it across all modalities. We'd like to be able to convert from image to text and text to image and understand video and all of those AI challenges so that when you type something in English, you can get an image result. If you give an image, you can get a text result or another image result, whatever it is. All of these things make sense and are, to a large degree, done today on the net, although not quite as coherently and as well as we hope to do them in the future. And then, of course, you'd like to do this with all the corpora of the world, of course, with due regard to intellectual property ownership. So you'd like to do this across all of these things. I think this is a grand challenge problem that computers are in the process of solving, and that we may not see it, but our kids will see it. Our kids, my kids who've grown up with Google, they're 11 and 10, they just assume that everything is available. You want a picture of something, you describe it, we'll show you the picture. If you have a picture of something, we'll find other pictures. All of these cross-modality things are there. They're already assuming they can get translations of language. So they just assume that now. And that's a new thing in the world, that's feasible. But in fact, if I give a talk at a university campus and ask your students how many use Translate today, about 80 or 90% use Google Translate now. So it's very interesting. It's very, very deep penetration of that notion. So there are lots of grand challenges. This is one of them that shows all of the transformations. Video to video is what's the recommended video. That's the usual mode of finding something on YouTube. We want to do it better because we want to do it based on theme, and theme is hard to understand. So that's a deep AI problem that we still want to work on. Image navigation is something, you've seen a new image interface from Google. navigation across images is a central part of that. So all of these things are going. Voice search is an extremely popular thing. Voice found an application in call center automation a few years back that was a big one. That was sort of the first really big application of voice recognition. The second one now is in voice search and voice input on mobile devices more broadly. And that's where we played a large role. And it's remarkably heavily used, and it's remarkably good and getting better because of that feedback system that I mentioned earlier in things. All this leads, I think this is all enhanced by what I often call hybrid intelligence. And this ability to extend the capability of people, not in isolation, based upon continual learning, is just working extremely well. So we're doing this in many, many places. You know, spelling correction at Google is based on this, and vast numbers of things are based on it. I see this continuing, and I see this as a major theme. Of course, it relates to the prodigiousness again. Without vast numbers of information sources and feedback on whether we do things well or not, we couldn't do it. So the prodigiousness leads to the ability to do this hybrid intelligence. And that's the one bet in AI that you can be sure will continue to really grow effectively. I think there's just no doubt about it. So lots of challenges here. What are all the applications? How do we address limits to where we don't have data to learn from? How do we get data? How do we integrate user feedback in acceptable fashions? So how do we do this from a privacy perspective? How do we integrate that user feedback? There are new signals we should be getting. So we desire to do deeper semantic analysis of text. So how do we get all the semantic signals that we want to enable us to learn meaning? And we're working on that. How do we explain why we reach conclusions based on machine learning algorithms? Machine learning algorithms come up with coefficients. We apply them and we get a result. But if a physician said, why has your system reached this diagnosis? We're not in a very good position to answer why. So that's a very interesting challenge, I think, in machine learning. Another problem with machine learning is we typically manage to averages or means, but variance is a big problem. So you don't want to have real bad results, even if the algorithm is, on average, pretty good. I've been very interested in what I call the combination hypothesis. How do we apply very diverse signals and apply them together? So how do we apply syntax, semantics, as well as machine learning together to do far better in speech or understanding images than we've done previously? How do we deal with devices of increasing variety and subpopulations that use them, like the elderly? And the elderly cannot deal with the cognitive complexity of a lot of what we build. And privacy issues are a very big one and a complicated and fascinating topic for all of us, no matter where we sit on it. There are societal implications, there are technical implications, there are legal implications, there are all sorts of things that come together as we find our way through this. So very interesting challenges here. And in many new domains of application, clearly these things are being applied in search and translation, speech and vision. But this hybrid intelligence, what about remedial education? I'll just go through one example in the interest of time. But if we had huge numbers of systems that were being used by students, we would find out what works and what doesn't work just based on usage. And that feedback would say, gee, when we teach students these kinds of things, when they've had this kind of a problem, they then solve their problem in the future. And if we show them this stuff, it doesn't help. So the possibility of applying machine learning in education systems, in my opinion, is huge and might allow us to do really personalized education in a way that would never be feasible with humans doing everything. So that's just an example, and there are many, many more. Some of these you'll recognize, some of them you may not sure what I'm getting at. Be happy to talk more later. So it's a real exciting time. I tell students when I give talks on campuses, some of them say, we're too late, right? Bill Gates already invented DOS, and we're too late. Larry and Sergey already invented Google and whatever. I don't get it. I hope you exude this as well. The field is far more interesting today than when I was a student. I mean, it was a big deal at that time to write a programming language interpreter in a machine-independent way. that could be compiled on different machine architectures. I mean, that was a big deal in programming languages to be able to do that. Today, it seems trivial in comparison to these challenges that we, as computer scientists, get to lead. So it's a really exciting time. We're trying to help in university relations to nurture universities and to nurture our relationship with the universities. And we think about recruiting, of course. We think about supporting research that benefits everyone and being relevant. So just a few things about us and what we're doing now. Remember, we're about 12 years old as a company, so we've grown this fairly fast, as many things at Google. In fact, I would say the whole programs are more or less double what they were a couple of years ago. So we've doubled this kinds of things we do with universities in about the last 2 years. Maybe not the numbers of internships. That's one thing that's not grown quite as rapidly. So at Google, we have now about 800 plus internships around the world. So that's a tremendous thing. That means that for every Google employee, there's every 10 employees is an intern, something of that form in engineering. It's extremely valuable to us. I do roundtables with interns. I will do 5 or 6 roundtables a summer and meet 60 interns. It's by far the highlight of my summers is doing that. I mean, I enjoy that. I love doing this talk too, but the intern roundtables are even better, to be frank. It's just wonderful. They all have a great time. And intern programs are great. We certainly love them. We generate hundreds of full-time hires from university campuses. It's a kind of a growing percentage of what we're doing. We have a lot of scholarships that we provide, in particularly reaching out into underrepresented groups in computer science, as you see in this list. Many of you know about the Anita Borg fellowships or the UNCF fellowships, et cetera. We have a lot of desire to increase the pipeline of people that want to go into computer science or fields, perhaps fields even related to computer science later in life. So one point of leverage, I'll discuss it probably a bit more, is can we train high school teachers to excite high school students about computer science so that when they get to your universities, they don't conclude that CS is boring and old-fashioned and already done. So that's something we've been doing, and you see the numbers here. 1,500 high school teachers we've trained, and if you look at their fan-out, the number of students they teach, we think we've gotten impact on nearly 100,000 high school students. We have a program called the Summer of Code, and I'll describe that a little bit more in a minute in this chart. So the idea is that for many students, rather than getting a job at a fast food restaurant, of course I have nothing against that because I did that for a couple of years myself. It was a good experience also. We would like students to have an opportunity to do programming in summers. So we fund a large number of open source efforts and enable those open source efforts to recruit students to work with a mentor to achieve something in that open source community. So this year we'll work with, we'll support 1,000 students in 70 countries and over about 150 organizations. So it's a big program, and we've been doing it for a number of years. I talk to many of the open source leaders, and they love it. And there's a growing demand to keep doing this as there are more and more open source things going on. It seems like a tremendous way for people to get involved. A little bit more on CS for high school. We do this not ourselves. We don't invite all these teachers, say, just to Google and then try to teach them. We do it through universities because that's where the skill is in teaching. So these are some of the universities that we're involved in and some of the people that have been involved in this. Each university may do things a little bit differently. We're okay with that. There can be variation. For example, Scratch is heavily used in some places and perhaps not elsewhere, and that's fine. There are many ways of teaching this field. There's not a single right way, but getting to lots of teachers and exciting them so that they can do a good job is, I think, very important. Now, let's turn to research for a minute. In the last year, we funded 230 projects in our research awards program. We have 3 calls per year for proposals. The next due date is mid-August, and we'll have some additional awards, a smaller number of awards in that domain of marketplaces and auctions and such things that I mentioned is important, with a due date on October 15th. There's a email address, researchawards@google.com, for further information. Also, you can look at our website, which has an enormous amount of information on it. That's research.google.com. We have a visiting faculty program. We have about 20 visiting faculty members here at any time, either, and I mean here broadly at Google, maybe in overseas or in New York or Cambridge or Pittsburgh or wherever, or Mountain View. So there are about 20 ongoing. That's tended to be a good thing. We tend to like it when we have a clear project in mind. So the faculty member can do something at Google that they've wanted to do, that we want to do, and at the end of the year that will have happened. And that's something that we think is mutually beneficial and quite exciting and a good thing for a faculty member to periodically do. A year ago, we announced a PhD fellowship program. So last year was our first year we did it in North America. We had 13 fellowships that we supported. These were named fellowships, the Google Search Fellow, for example, or the Google Machine Learning Fellow. And then we now have expanded that outside of North America to the rest of the world, and we've done about double the number this year, as you see on this. So that will keep growing, and these are usually 3, maybe 4-year stipends, depending upon the student. I guess 3 years typically. So the number will keep building arithmetically over time as the students get through. One thing we've introduced as well in what we've done to grow our commitment to research in the universities is to do some focused research grants, which are bigger than our usual grants, in some areas where Googlers are really interested and committed to being advisors and kind of involved in the projects. So we're doing that in energy efficient computing and privacy and security, in open mobile data collection, on a project involving this kind of hybrid intelligence with machine learning and new applications and people in the loop, in can I pronounce that? Culturonomics. That's a hard one to pronounce for me. I have a slide on that one, and on worldly knowledge I have a slide as well. And we're just about to do one in auctions and markets. So an interesting one that we're doing now is called culturomics. What we think is feasible is to, and more importantly, Erez Lieberman, and I know it's feasible, that it's possible to do an immense amount of learning from the Google scanned-in books corpus. So one can do processing of tens of millions or millions of books, whatever the number is that's available under copyright availability, to prove or disprove or just learn what's happened over time. So Dr. Lieberman, for example, a couple of years back, looked at word frequencies in these large corpora. And he analyzed the frequency that irregular verbs became regularized as a function of their usage. So he looked at irregular verbs that were used a lot, and saw that they persisted. And irregular verbs that were rarely used died out, and they became, regularized in the normal patterns of language. So he was able to conclude that and wrote an article that was quite well received based on that actually described the phenomenon and modeled how it happened. There are many more things like this in it. So we're very interested in the application of machine learning and these kinds of analysis, vast data-based analyses, to large bodies of information. And we think that's entirely consistent with our mission of trying to organize information and make it universally accessible and useful. We're working with Tom Mitchell and other faculty members, as an example, in extracting facts and context. So many of us, I have been for many years, even though I'm not an AI per se, we've always been interested in semantics. And the question is, do we have to teach semantics to computers, as in, say, Doug Lennett's work, or can we learn it now, given all of the inputs in vast amounts of data? So I'm very pleased to see Tom's working on the learning side of this, which is, if possible, much more scalable and adaptable and stays in sync. It's a much more scalable thing to do worldwide. So that's a focused problem we're working on. We're supporting the AMP Lab at Berkeley. I would say broadly, given that I presented it earlier, I would call this a program in hybrid intelligence, broadly, to work in that domain. And Dan Sturman, just to give you an idea again of how things work at Google, Dan Sturman is based in the New York lab. He's an engineering director. He's actually a PhD in computer science with quite a research background in distributed systems, but he leads an engineering team. He's the group working with the AMP lab because we're actually very interested in how this will affect systems in the future. We're looking at how we bring technologies to schools and universities. We have a lot of courseware. We make apps available. I'll describe that. I want to just mention App Inventor for a moment, and we do provide, occasionally we find ways of providing data that have no negative privacy implications. So we have Google Code University. There's an enormous amount of course material, and not just raw text of what you might put in a lecture, but problem sets and slides and tutorials on a bunch of topics that we think are really relevant and useful in universities. So these might be useful for you to think about in augmenting education you do. It could even be done by other groups in the university that use these, like a computer science club or something like that, to augment the curriculum and make it very relevant and practical for people. So that's something we do. We are making our apps available. Many universities in many ways use Gmail and other apps just to save money and to allow for the benefits of sharing through the cloud. I wanted to mention this effort. This was an example of a really interesting thing that started when Hal Abelson from MIT came to Google. Is Hal, are you in the room, Hal, or if he's here or not? Okay, I would say the same thing anyway. But he came and had this idea of building a programming language that would be aimed at I would say novices, and that would bring together the excitement of visual programming, as in like Scratch or whatever, the programming that was able to mash up all the cloud-based abstractions that we now are beginning to believe just exist, like location services or chat or email or image repositories and the like, calendaring, all those kinds of abstractions or objects that exist in the cloud. And then also, finally, the third part of it is all of the objects that exist on the handheld device. So the display, the microphone, the fact that it's always with you, so when you get its location, it's your location, the ability to play music, all of those things, try to bring those all together in one programming environment that would be highly motivational if easy enough and seamless enough for the sort of CS, the intro CS course for everyone at a university, not say for majors, but for everybody, and would perhaps in fact be useful in the high schools and maybe middle schools. So he worked really hard. He, I think, extended his stay here somewhat, has worked part-time at MIT, found MIT interns to work on this. A lot of Google engineers worked on it. And we put this out now. Our main challenge, of course, is supporting the demand, because first it's evolutionarily better, so we have to support demand as it improves. And just it's a lot of people. I mean, a huge number of people signed up. So we have this in a sort of early form of supporting some of the demand now and gradually turning it on to more and more people. But this could have a very big impact. In any case, it's certainly illustrative of the kind of bet we want to make with a visiting faculty member. It's what we do. Another example of something that turned out very well is Google Sky, which also came from a visiting faculty position. Someone who was interested in the Google Earth ideas, but knew a lot about astronomy. So, research.google.com, more information about these things. Check the site. My final words, this is really the last chart. Share, please talk to each other, share with us, we'll share with you. We'll try to learn. Please critique us, both the format of the event, we're glad to hear it. I can assure you Hannah critiqued me last night in very blunt terms, so that was very good. Please keep it up. She can give you directions. No, it's great. I sent her a thank you note today, actually, for it. Meet old and new friends and have fun. And consider, as we go through these foci on security, cloud, and social networking, how they impact and are impacted by these other tectonic forces that I mentioned around prodigiousness and hybrid intelligence and vast distributed computing, et cetera, how all those come together and support and are impacted by this. So thank you very much for coming, and thanks for listening to me. Now, I could take a couple of questions for just a minute. I started a few minutes late, so if there were any questions on logistics, or I'd be happy to pass those questions to Hannah or try to answer them, or any questions or thoughts on what I said or didn't say, that would be fine. Yes?
Something you didn't mention in sort of these broad platforms is context. It seems like when you go to the mobile Google app, it knows where you are. That may be, I don't know internally, is that affecting search only? Is that affecting voice recognition, other things? Is there something you see in the world about making this kind of exploitation of context available at that platform level along with devices and information sources and the rest?
Yeah, so context is a broad term, right? It doesn't just mean location. It means maybe what's the user doing, right? So what you should show me, when I was madly adding a few charts this morning wasn't very much. But if I was at home, surfing the web before bedtime, I'm kind of looking for interesting things to look at. My context, my mental state is somewhat different. You're right, geolocation is an important one. So I think context services are something that it would make sense to have some open standards around and be able to provide. We of course have to deal with privacy implications of that. So that's a kind of thing where transparency of what's happening in clear announcement to the user community with a lot of focus on human factors is necessary if you're going to do it. But I think context awareness is extremely important. And you're right, it is. I mean, if I say pizza restaurants and it gives me the name of my typical pizza restaurant in Mount Vernon, New York, near where I live, while I'm out here, that's just stupid. Right? I don't want that. I mean, Google might say, see how smart we are? Remember, you always go to that pizza restaurant. Well, I'm in Mountain View, guys. It doesn't make any sense. So we need that. Yeah, question.
Do you have a wish list for us in terms of design curricula? Are we keeping up with the real world? They don't mean just the technical. Are we teaching the right problem-solving skills? Are we teaching the right culture?
Well, I suppose I give this talk, I think, right, partially to try to tell you what I think we as a community will be addressing in the future. So these issues of scale and privacy and security and all these things, the main topics of this before, we would like you to keep them in mind as you give these courses. Draw examples from them, aim problem sets in that domain. But I think the core of the field is algorithmic, right? I mean, Knuth Volume 1, 2, and 3 serve us well, or whatever the modern renditions of that are. Understanding formal language theory, and that's among the most beautiful results in our field. I think they're very important. So in my judgment, the problem-solving skills that come from algorithms and the study of algorithms and data abstraction and modularity are very good. We have to continue to emphasize that. I think in terms of programming, we at Google certainly like people to program a lot. So we like programming classes with lots of programming. Group programming is excellent because that's more the real world than sitting in your dorm room and doing something entirely yourself. So opportunities to learn a lot about programming are valuable. The field is now specialized enough that I think we would like students to have some ability to choose advanced foci in different domains among undergraduate and masters. So, there'll be people that take a lot of security. There's a lot of stuff in that today. It's a sub-area, et cetera, and there are many sub-areas. So a diversity of opportunities for students. I don't think we could say, gee, everyone should come out with a security course, because not everyone should, right? We don't need everyone to be an expert in absolutely everything. So one of the things maybe to keep in mind is the diversity of the field now, that it's now an old enough field where there is a lot of specialization within it. So it's a long answer. We're quite happy with a lot of students. We hire many, but just I would just say, if I were a faculty member, I would keep in mind where are things going and how do we stay relevant to that group of things.